We are going to look at an example involving the radioactive decay of iodine 131. With radioactive decay examples, the rate of change of a substance Q is proportional to its size. And Q is equal to Q at 0, that is just the initial amount of the radioactive substance, times E to the KT, and K is the decay constant. With radioactive decay examples, the rate of decay is expressed in terms of half-life. Half-life is just the time required for half of any given quantity to decay. Let's now look at the radioactive decay of iodine 131. We're told that the half-life of iodine 131 is 8 days, and we are to suppose that we start with a 200 milligram sample. We want to first find an expression for the mass that remains after T days. We'll start by letting Q be the amount of iodine 131 at time T. We are told that we start with a 200 milligram sample, so we can say that Q at 0 is equal to 200 milligrams. And then we're also told that the half-life is 8 days. That just means that the amount of iodine at 8 days is going to be 1/2 of the amount that we started with, which was 200. So this tells us that Q at 8 days is going to be 100 milligrams. I'm going to go ahead and highlight both of these because we are going to need these when we find what Q is equal to. The rate of change of any radioactive quantity is proportional to its size, so we can say that dQ dt is equal to K times Q, and that just means that Q is equal to Q at 0 times E to the KT. We know what Q of 0 is, so we can plug that in, and we can say that Q is 200, that's just Q of 0, times E to the KT. Now all we have to do is find K, and we can use that Q of 8 is equal to 100 to get that. Q of 8 is then 200, E to the K times 8, and that is equal to 100. Let's divide both equations by 200. So we get E to the K times 8 is equal to 100 over 200. So that's just 1/2. We are solving for K. And to do that, we are going to have to take the natural log of both sides. That'll just get K out of the exponent. So we have ln E to the K times 8 is natural log of 1/2. We can pull the 8K out in front. So we have 8K ln of E is ln 1/2. Natural log of E is just 1. So this gives us that K is equal to natural log of 1/2, all divided by 8. Now we're going to go back up to this expression right here, and we're going to substitute in that K is natural log 1/2 over 8. So we have Q of T is 200 times E to the 1 over 8 times natural log 1/2 times T. Now let's regroup what is in our exponent. I'm going to write this as E to the natural log 1/2 times T over 8. And then we know that E to the natural log of 1/2 is just 1/2. So this is 200 times 1/2 to the T over 8. And that is our expression for the mass that remains after T days. We now want to find out how much of a sample remains after 24 days. Let's write down the expression for Q that we just found. We found that Q was equal to 200, 1/2 to the T over 8. Now we're going to substitute in that T is 24, so our amount of iodine at 24 days is equal to 200 times 1/2 to the 24 over 8. So this is 200 times 1/2 cubed. So this is just 200 over 8, and that is equal to 25 milligrams because our iodine had a unit of milligrams. So we now know that after 24 days, we have 25 milligrams of iodine 131. Let's look at the last part. We want to know how long will only 5 milligrams remain. Whenever you're asked for how long, that means you're going to be solving for time t. Let's again start with our expression for Q. That's our iodine. So this is 200 times 1/2 to the T over 8, and we want to know when is this going to equal 5 milligrams. Let's go ahead and let's divide both sides of our equation by 200. So we have 1/2 to the T over 8 is 5 over 200, which is just 1 over 40. Now to solve for T, we need to get T out of the exponent, so we're going to take the natural log of both sides. So we have natural log 1/2 to the T over 8 is natural log of 1 over 40. We can now pull the T over 8 out in front. So we have T over 8, natural log 1/2 is equal to natural log of 1 over 40. Now to find T, we're going to multiply both sides of the equation by 8 and divide by natural log 1/2. So we get T is equal to 8 natural log 1 over 40, all divided by natural log 1/2. When I put this into the calculator, I get that this is approximately 42.6 days. So in 42.6 days, there will be 5 milligrams of iodine 131.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.